minus a to the fourth. That can be factored as x minus a, x to the third, plus ax squared, plus a squared x, plus a cubed. A to the fifth, or sorry, x to the fifth minus a to the fifth, x minus a factors out, and you get x to the fourth plus ax cubed plus a squared x squared plus a cubed x plus a to the fourth. X to the seventh minus a to the seventh would be x minus a, x to the sixth plus ax to the fifth plus a squared x to the fourth plus a cubed x cubed plus a to the fourth x squared plus a to the fifth x plus a to the sixth. Okay, so that's what my notation means over here. So what was majorly important is that the x minus a's cancel or factored out. So that I'm able to cancel it in the denominator. And then once I'm able to cancel that in the denominator, then I no longer am getting 0 over 0. Okay, I'm no longer getting 0 over 0. And I can then just plug the a in to evaluate the limit. Okay, so I would get a to the n minus 1 plus a times a to the n minus 2 plus a squared times a to the n minus 3 and so on. And if you remember your rules of exponents, what are you supposed to do to the exponents when the bases match? Or what are you allowed to do if you're multiplying and your bases match? Add them, right. So if, for example, if I have a to the fifth times a squared, that's a to the
7.
7. So if I add 1 plus n minus 2, what does 1 plus n minus 2 equal? N minus 1. So this turns into a to the n minus 1. What does 2 plus n minus 3 equal?
N minus 1.
N minus 1. And n minus 2 plus 1 is again n minus 1. So all of those terms are n minus 1. And I can probably more easily tell how many I'm going to have. When I had a power of 4, how many terms were here?
4.
When I had a power of 5, how many terms are here?
5.
When I had a power of 7, how many terms are here? 7. So there are n of those. So if I add n of the same thing, I can just multiply n times. So I get n times a to the n minus 1. And so what that means is if my function was x to the 7th power, the derivative is 7 times x to the
Person.
6th power, n minus 1.
Oh, yeah.
N minus 1's the new power. I multiply by the old power, I subtract 1 from the power to get the new power. If my power is x cubed, what will the derivative be if my function is x cubed? 3x squared. And this rule applies even when your power is not an integer. It's just the proof works out pretty cleanly if you do it for integers, and like I said, in real analysis, there's a proof that makes the connection between the two. But the rule applies, so if I had x to the 2.7,
2.7x to x to
1.7.
1.7. I think I will stop there. I mean, we